In this video, I'm going to walk you through lesson 2 of unit P1. All right, so this lesson has 4 investigations. We're really going to uncover all the parts and functions of electric circuits. And so we're going to navigate into the lesson by going over those pictures that you assign students to take around the community for home learning, about things that represent some things in the electric grid. So it could be outlets, or if they live near a power plant, they might take a picture of that, or anything that has to do with the electric grid. And so we're going to look for patterns in those pictures and what they might help us figure out. And then we're going to talk safety. Now, you're going to be using electric power strips for these investigations, and it's very important that you cut the plug off. So here is the slide that helps you talk about safety precautions and how we have an ethical responsibility to be safe during scientific investigations. And we're going to talk that it's dangerous to tinker with a power strip if it's plugged into a wall. Well, why would that be? So it may seem obvious, but please emphasize the danger here. So once we've talked about that, and please make sure I'll talk about it in the prep, that you've cut the end of the power strip off that plugs into a wall so kids can't accidentally plug it in. Then you're going to conduct 2 investigations, and you're going to begin with this handout. And you can see on the handout that there's 2 parts to it. And so part A, they're going to, after investigation A, they're going to kind of describe or list the key structures or parts that will help explain how the power strip works. And then in part B, they're going to draw and label a diagram to explain how the structures and connections are able to transfer energy to those light bulbs. And so this is the handout that goes with investigation A and investigation B. And there's some slides to support each investigation. Slide A basically just gives them some criteria and constraints. They're going to use the screwdriver to unscrew the power strip. And they're going to look at what's inside, and they're going to try to identify the parts, really an exploration of what's inside of a power strip. Please remember to cut off that plug so they don't plug it into a wall. Investigation B, they're going to try to add 2 light bulbs using alligator clips to the surge protector. Now, a battery is powering this surge protector, and so it's exploratory, and they have to figure out how to get the light bulbs to not only turn on, have the same brightness, but go on and off when the switch turns on and off. So that is investigation A and B, and they're going to analyze those structures, and there's a slide to support this. So we're going to analyze some structures and functions of the switch. We're looking at the differences of what happens in these circles right here. It looks like we've got some things connecting and some things further apart here. Anyways, we're going to look at the structure of the switch, and then we're going to develop a model. And so this model is going to be the first one they do themselves on their handout in part B. And they're going to try to explain how these structures and connections enable it to transfer energy and label the parts. This is a scaffold to then build a model as a class. Now, if you are not on block schedule, you're probably going to have to clean up at this point, and you're going to turn in the power strips and the materials. They'll need to rebuild that power strip, reassemble them, because your next class is going to come in. And so it's nice to have 2 bins. This is your investigation A materials, investigation B materials. After we do that, we read this article about electricity related parts. And this article goes through all the common parts that you need to know about, some of which we just saw in the surge protector. So we're talking about what is a complete circuit, what is a circuit breaker, what is insulation wrapped around the wires, what is a ground wire, and what are light bulbs. And so we're reading about those main parts that are related to electricity. And then we're going to introduce our class model, and we're going to make, there's a lot of prep for this anchor chart. It's going to be described in the prep video. But basically, as you go through with the class, you're going to add on light bulbs and electric outlets to the wires. So the ground is represented by the green. This label gets moved over to label that green with, that's actually a green yarn there. You got this red yarn that connects to the red wires and the blue to the blue wires. So you're just showing how to make a complete circuit. You're showing all the key structures. We're going to define what a closed switch does. Provides a second unbroken metal path so energy can transfer, how the switch works. So the one thing you're going to have to do is remove the light bulbs and the switch and the electrical outlet and this definition between classes. So might be useful to have sticky notes, or just, I like this blue tape that works really well, but no, you're going to have to move things on and off between classes. Once we develop the class model, we start thinking about circuit breakers and what circuit breakers are that are connected to our house. And so look, our model kind of comes back here. Ground, we're going to describe a little bit more here. The ground actually goes into the ground, a safe place for excess energy to go, and where your light bulb will be connected to. So this really transfers from our model to real life. And then what is a circuit breaker? And it's an electric panel where the outside wires are attached. And we're going to talk about the role of this circuit breaker and what happens if there's excess energy in the system, especially if there's a blackout, and has anybody experienced any of this? So then we're going to move into investigation C, and this investigation, we're actually going to assemble some buildings. Now, this is fun, and this is called an electric city. It will come back later in the unit. Students can build buildings out of cardboard, or you can just make a paper tent. This looks like one side of paper. And so they're going to be different buildings that are representing in our community. It could be a hospital, a school, a home, a grocery store, anything that's in the city. They need to connect their building to a substation. And so this is just directions on how to assemble buildings out of cardboard. But this is what the substation will look like. So you've got the surge protector. It looks like it's still dissected. So if you have a block period, they don't need to reassemble them. Or you might have some surge protectors set aside just for substations. And so you can see that we've got these alligator clips that are connected to the parts of the surge protector that we've already looked at. You've got, this would be, connection to one building, connection to another building. And so they're going to light up light bulbs in the different buildings in the community. And you really need to develop what a substation is and how many different buildings are connected to the same substation. And so we talk about how this model can show how multiple buildings can connect to one energy source. And then we carry out D, which is going to simulate broken circuits and short circuits. And so we're going to simulate this using a paper clip and a scissors. And so you can see that this would, when you open the scissors, would represent a broken circuit. And then this paper clip is going to represent a short circuit because that energy is going to transfer to the paper clip instead of going where it needs to go. We're going to discuss the role of circuit breakers again, and especially in the context of a broken circuit or a short circuit. If you've got the branch that falls and electricity is going into the branch instead of where it needs to go. We talk about who's experienced this. And then we're going to add some words to our personal glossaries, which would be switch, circuit, ground, and substation. So this is a pretty big lesson, lots of hands-on, lots of fun, and enjoy building your electric city.